السلام عليكم ورحمة الله وبركاته.
السلام وبركاته.
طيب، بسم الله الرحمن الرحيم، الحمد لله رب العالمين، والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. الله يصبحكم بالخير. طبعا صار في تعديلات على توزيع العلامات في الكيمستري 101، وأنا أرسلت لكم الآن التعديلات، أرسلت لكل الطلبة على الكوردينيتد كورس. الشيء الوحيد انه الغينا كويز 2، وحيبقى فقط الميدتيرم ان شاء الله حيكون فيس تو فيس، يعني ان شاء الله حنقابلكم في ايام اختبارات الميدتيرم ان شاء الله. حيكون الميدتيرم في الشبات من 1 إلى شابتر 5، وبعدين أيضا شابتر 10. فإن شاء الله تستعدون وتكون الأمور ميسرة بحول الله تعالى.
دكتور، ما تحس انك
نعم؟
ما تحسون انه كثير 6 شباتر؟
ما يعني لا، ما هي كثير ترى. احنا نسوي في 4 شباتر.
المواد الثانية عندنا بعد.
طبعا للأسف هو الوضع في هذا الفصل غريب، ولكن احنا نسويه في 4 شباتر. المرة هذه حنسويه في 6 شباتر، لأنه شابتر 1 و 2 اوريدي انتم اختبرتوا فيه، وشابتر 1 و 2 بسيط جدا، فالتركيز على ال4 شباتر الحقيقة، وحيكون الاختبار في 4 شباتر. ولكن يا ولدي أيضا لا تنسى أنه الفاينل حيكون على 12 شابتر. فنعم فيها دراسة يبغى لها شوي شغل، ولكن إن شاء الله مقدور عليها.
دكتور،
نعم.
هل الأسئلة راح تكون صعبة ولا يعني نورمال نفس
نورمال جدا، زي الأسئلة اللي تاخذونها. لو رجعتوا للماجر القديمة حتجدون كل الأسئلة موجودة، بس الاختلاف المرة هذه إنها في 6 شباتر. أول كنا نعطي 2 ميجر، وكل ميجر فيه 4 شباتر. الآن حيكون ميد تيرم وفاينل، وهذا الميد تيرم عليه في 6 شباتر إن شاء الله.
دكتور
نعم.
خلوا الأسئلة أسهل عاد يا دكتور. الدراسة عماد ما هي بنفس حضوري يا دكتور. في فرق أكيد في الاستيعاب والفهم والتركيز.
يعني إن شاء الله بحول الله، الله يعين.
دكتور،
نعم.
هو بيكون 25 سؤال صح؟
بيكون 25 سؤال. الله إن شاء الله. نعم.
25% عليها صح؟
وعليه كم كان عليه؟ 5 بالضبط. الله 25.
اي طيب يا دكتور، كل سؤال يعني 1%، والله حرام.
ها؟
يعني لو ضيع سؤال يروح عليه 1% كذا على طول.
والله زي ما قلت لك الوضع غير سبيشل. كلنا نتحقق الظروف هذه، مو بس انت، حتى احنا نفس الظروف يعني. ولكن شده وتزول، وبعدين في نهايه المطاف الامور حتكون افريج. فاحنا يعني الافريج حيتاثر كله، سواء بوزيتيف او نيجاتيف، حيكون التاثر على الجميع ان شاء الله.
بس دكتور يفرق من ناحية الجريدات العالية.
نعم.
الاي بلس والاي عادة تكون يعني ما تتأثر واجد.
والله كل هذه الامور يعني ما حناقشها الان، لانه زي ما قلت لكم الوضع حاله خاصه، واحنا مارين بحاله خاصه. ولكن ان شاء الله في مثل يقول الموس على كل الروس تصير نفس الاثر عليه يعني. فهذا المشكله اللي احنا فيها الكل واقع فيها، مو بس كل طلاب الكيمستري 101. واحنا حنعاملكم زي في النهايه زي ما نعامل طلاب الكيمستري 101. الظروف اللي كانت هناك مختلفه، ولكن لما ناخذ المعدل حيكون ان شاء الله في الوقت هذا او الاوقات الماضيه مشابه، بحيث ان احنا نوازن بين المعدلات هذه والمعدلات هذه، وتطلع ان شاء الله علاماتكم في النهايه بنفس العمليه يعني.
دكتور، بس عن الكويز الجاي متى بيكون؟
اي كويز حقنا يعني؟
ايه، ما بحق الكوردينيتد.
إيه يوم الخميس كنت ابغاه اخليه الاربعاء، طلع شباب عندهم اختبارات فبضطر اخليه في نفس اليوم.
دكتور ما يصلح مثلا تأجل الأسبوع الجاي، لأن صراحة الخميس يا دكتور يعني موعد جدا غير مناسب لمعظم الطلاب يا دكتور.
الاسبوع الجاي
بالليل وخميس يعني الطلاب بدهم يغيرون شوي، يكون طالعين من ميجر أكثر من كذا.
الاسبوع الجاي
فلو
الخميس الجاي حيكون عندكم
يكون ذاكر الشابتر 4.
اعطيكم كل اسبوع يكون بعطيكم كويز.
يعني
خل الأسبوع اللي بعده كوزين قبل الميد تيرم عادي، بس
انا ما استطيع، ما اقدر اسوي كذا.
دكتور بس يفضل ما يكون بالليل.
تقدر يوم السبت يا دكتور؟
نعم ناقشنا
يكون
هذا
يوم السبت.
زي ما قلت، انا كنت اتمنى ان احنا نخليه الاربعاء بدل الخميس، ولكن اذا صار شباب عندهم اختبارات ما اقدر. يوم الخميس هي الريستيشن، يوم الخميس اللي صار اني على اساس اخليكم مع بعض اخركم لليل فقط يعني، ولا هو الكويز في نفس يومه يعني.
طيب مثلا دكتور لو العصر مثلا تخليه.
شوفوا يا شباب، انا اخليه اي وقت، انا ما عندي مانع انه انا الكويز الان جاهز، لو تبغون اعطيكم اياها الان اعطيكم اياها، ما عندي مشكله، الكويز جاهز، ولكن الشباب ما يناسبهم الا في المساء.
طيب مشكله دكتور بس يوم الاربعاء يوم السبت. لا يوم الاربعاء قبل نهايه الكلاس يعني
شلون يوم الاربعاء قبل نهايه الكلاس؟ لا
يعني
المحاضره
الطلاب كلهم موجودين في الحصه، صح ولا مو صح؟
لا ما حقدر اسويها في المحاضره، ما حقدر اسويها الا في يوم الريزيتيشن.
طيب عندي سؤال دكتور.
طيب عصر الخميس يا دكتور ما يناسب الطلاب؟ اتوقع يناسبهم.
اي وقت الساعه 4
ممكن مثلا الساعة 4 أو الساعة 5 مثلا.
بعضهم
كل عصر ما يناسب.
الطلابات خلصت.
اي عادي على الاقل 6:30.
لا صح. ما حد
دكتور
عنده
المشكله مع الاربعاء في الليل. طيب
نعم
الاربعاء في الليل شو المشكله؟ في ناس معارضين يعني.
في ميجر في ميجر.
أوكي.
طيب دكتور ليش ما يستوي في وقت الكلاس اللي هو الاربعاء والاثنين؟ شو المشكله في اللكتشر؟
لاني ابغى اعطي ليكتشر.
لا اقصد ناخذ جزء ونعوض الجزء في الريسيتيشن نفس الشيء.
ما اقدر ريسيتيشن، ما اقدر اسويها الا ابغى المحاضرات تمشي زي ما هي، لان احنا متاخرين، انا الان متاخر ابغى امشي اسرع في المحاضرات.
طيب دكتور احد عنده مشكله مع السبت؟
شباب السبت فيه مياجر، فيه متان كمان، فخلاص خلوك زي ما هو.
احد عنده مياجر يوم السبت؟
ايه يا دكتور انا عندي ميجر.
عندي كمبيوتر انجينيرنج.
اذا نبقى على الخميس ان شاء الله.
عصر الخميس. طيب يا دكتور خلاص الخميس ثبت، عصر الخميس مثلا بدل من
اكتبوا لي كلكم انكم موافقين 100% ولا واحد معارض انه يكون.
عصر الخميس فيه اختبار عندي، وفي عند كثير من الناس اختبار.
خلاص انتهى.
عربي.
قاضي الامر يا دكتور.
طيب احنا متاخرين وانا ابغى اخلص اليوم شابتر 4. الان احنا اخر شيء وصلنا في شابتر 4 هو اللي تشوفونه الان امامكم. تكلمنا اخر شيء عن التايتريشن، الاسيد بيس تايتريشن، وقلت لكم انه طيب بسم الله الرحمن الرحيم. آخر شيء last thing I talked about was the acid base titration, and I told you that this is burette, this is flask, and this is called indicator. The indicator change color when you put it in a liquid like this, and you add the base to the acid to make titration. Very important word you must memorize, and you can tell how much the acid is available in the and you reach the equivalence point. Equivalence point means acid equal exactly base. in number of moles. Number of moles of acid equal the number of moles of base. You have to be careful with this. And of course, what is molarity? What's
number
molarity?
of moles multiplied by Avogadro number.
Number of moles divided by what?
Avogadro number.
No.
Water volume.
Volume. Volume. Moles per liter. Moles per liter is the molarity. All right, you have to be careful with this. That's why titration experiment student find 25.49 milliliter of NaOH solution need to neutralize 0.7137 gram of KHP. And the molar mass of KHP, this is KHP, the molar mass is 204.2 mole grams per mole. Can we change this to mole?
Yes, divide mass.
Yes.
Molar mass.
KHP equal to 204.2 gram. KH gram goes with grams, and you have the number of moles. I want you to do it quickly. Divide 0.7137 divide by 204.2.
3.4 multiplied by 10 to the power minus 3.
Or
minus 3.
Minus 3 mole KHP. Now, if this is the number of moles, when we reach endpoint titration, in titration experiment, when we reach endpoint, how many moles KOH we need? NaOH, sorry. How many moles NaOH? Hello?
Hello.
What is? How many moles NaOH do we need?
نسوي نفس الدكتور اللي كنا نسوي أول 3.4 ضرب 10 صار ب3.
10 to the power minus 3 mole NaOH. Now, this amount was available in 25.49 milliliter because that's the amount we needed to make the titration. Then what's the molarity? 3.4 times 10 3 moles divided by 25.49 times 10 to the power minus 3 to make it liter solution, and we have the answer. Is this clear? Okay, give me an answer quickly.
.37 multiplied by 10 to the power minus 3.
Doctor, why did we equal the number of NaOH moles with the...
What's titration? What's titration? Yes? Titration means adding the same amount of acid to the base or the base to the acid. Now we are adding NaOH to this KPH. When we reach the end point or needed to neutralize, and neutralize means neutral, no more acid, no more base, titration. Then if we use this mole of KPH, how many moles of NaOH do you need?
The same number.
Same number, exactly. That's the meaning of titration. And when you reach the neutralizing neutralized point or end point. If I tell you, you reach the end point or equivalence point, all of these words are exactly equivalence point. All of these words, end point or equivalence point or neutralization, are the same word. Is this clear? Everybody?
Yes.
Yes, very good. And the molarity is point. No, it's wrong. What you gave me. Oh, this number is wrong. Divide 3.4 times 10 to the power minus 3. Divide by 20.
0.13.
Actually, it's wrong.
0.13, doctor. It is 0.13, not 5.
Exactly. 0.137 molar. That's the answer. Is this clear? Hope so. Good. Next. What volume of 0.203 molar NaOH solution is needed to neutralize? What does neutralize means?
Endpoint.
Endpoint or equivalence point. Okay, I have 25.0 milliliter. I want to change it to liter to make it times 10 to the power minus 3 liter. And I'll take the milliliter out. Okay, and I know the molarity times 0.188 molar H2SO4. So how many moles do we have? Quickly.
4.7.
4.7 times 10 to the power minus 3 mole, or 4.7 millimole. Millimole means 10 to the power minus 3, it goes away. That's all. Now, when you neutralize, how many moles of NaOH do you need? That is moles H2SO4.
2.
If what we calculate here is the moles in H2SO4, 4.7 millimole. How many moles in NaOH do we need?
هذا the number.
No. Look at the equation.
0.203 multiplied by
half the moles of H2SO4.
No, twice, not half. Double. 2 times 4.7 millimole. Don't forget this, because of the equation. We calculate the number of moles of H2SO4. We need twice the amount by the equation. So this will be 9.40 millimole. Millimole means 10 to the power minus 3 mole. Okay, now if you know the number of moles or millimoles, and you know the volume, which is, or you know the molarity. You know the molarity, can you calculate the volume?
Yes.
How?
Moles over molarity.
0.203 moles per liter. So if I have 9.40 millimole times 10 to the power minus 3 mole, I will multiply this by 1 liter divided by 0.203 moles in NaOH. The moles in NaOH will go with moles in NaOH, and you have the answer in liter, which is 46.3 times 10 to the power minus 3 liter, or 46.3 milliliter. I hope this is clear. Can you see it?
Yes.
I hope so. Good. Next. Also, we can do redox titration. Redox titration, same thing. When we have a chemical reaction in which we have a redox titration, then we add one reactor, like in this example, where what happened to the manganese? What's the oxidation number of manganese here? What's the oxidation number of manganese?
+2.
No.
Here
1
+3.
No. No.
It's 4.
No.
1.
Usually when you want to calculate, do you remember what's always the oxidation number of F? What is it?
minus
+7.
What oxygen?
minus
-1.
Minus 2. How about hydrogen?
+1.
+1.
Excellent. Now, what's the oxidation number of manganese in here?
here
+7.
+7.
+7, exactly. +7. Why? Because there is only one oxygen here. -2 times 4 is -8. And this is the minus, so this is +7. What is it here?
+2.
+2. So what happened to the manganese? Was it oxidized or reduced?
Reduced.
Reduced. Why is it reduced?
Because it was electron.
Because you added what?
Electron.
5 electrons to it. 5 electrons to it. Clear? Okay. What's the oxidation number of carbon in here?
+3.
+3, is it? No.
+6.
Maybe you're right.
Yes, it's +3.
+1.
+3 for each.
Yes, +3. What is it here?
+2.
+4.
Plus what?
+4.
+4. So what happened to carbon? Oxidized or reduced?
Oxidized.
Oxidized.
So this is an oxidation reduction reaction, and this is the result of the oxidation reduction reaction. Same thing with this problem. Here, we want to know, we are reacting, what's the oxidation number of iodine in here?
0.
0. Yes, itself, exactly. What's the oxidation number of iodine in here?
-1.
Minus 1. Good.
1.
All right. Very good. So, what's the so there is oxidation reduction. We don't want to go into the others because it's complicated. I don't want to go to the others, but there is this reaction, oxidation reduction. Now, let me tell you now, we added iodine to, this is vitamin C, and there was a reaction. There was a reaction like this reaction. We know that how many moles of iodine required to react with vitamin C?
1 mole.
1 to 1, exactly. It says here, in order to reach the end point, we needed 29.25 milliliter of 0.100125 molar iodine. So how many moles I2 do we need in this reaction? You have the number of milliliter, the volume, and you have molarity. How can you calculate number of moles?
Multiply the molarity with the volume.
Exactly. So you multiply 29.25 times 10 to the power minus 3 what? Liter. I multiply by 10 to the power minus 3 to change it from milliliter to liter. Multiply this now by 0.00125 moles iodine divided by 1 liter solution. 1 liter solution. So what's the number of moles?
3.65 multiplied 10 to the power minus 5.
3.65 times 10 to the power
minus 5.
Minus 5. Who got the same answer? I don't know what's the answer. Is it correct?
Yes, it's correct.
Okay, very good. Then how many moles vitamin C do we need? This is vitamin C.
Since it's 1-to-1, so it's the same number of moles.
Which is what?
0.00125.
That's 5. Then how many grams is this? Can you change it to gram?
Multiply by
the molar mass.
Which is what? Give me the molar mass. Calculate it very quickly. We know that carbon is 12.01. Hydrogen is 1.008. And oxygen is exactly 16.
One 76.124.
1 to 76. Repeat.
176.124.
Moles will go with moles and you have the answer. Okay, what's the final answer?
Six 6.4 times 10 to the minus 3.
6.4 3. Who got the same answer?
Yes.
Yes, it's correct.
Yes.
Okay, good. That's how you determine the mass. Let me see if it's correct. 6.44 times 10 to the power minus 3. You're absolutely right. It's actually 6.44, by the way. 6.44. Right. This is the end of chapter 4. We finish here and we'll right away, because as I said, I'm already late, so I'm going to move to chapter 10 right away. All right? Okay. All right. Bismillah ar-Rahman ar-Rahim. Let's start chapter 10 after that right away, and I'm already late, that's why. Chapter 10 after 4, we will go to chapter 10, not 4. And okay. All right. What is chapter 10 about?
Yes.
Yes. Yes. Yes. All right. We're going to talk about the gases. Gases. How are they, and so on and so forth. And we want to know certain facts. First, when you put any gas in any volume, For example, let's assume I have this bottle and they have only 3 molecules of gas. What's the volume of this 3 molecules of the gas? This bottle, right?
The volume or
this bottle. If I make the bottle bigger, still I have 3 molecules only. I did not change the number of molecules, but what will happen to the volume?
Increase.
Greater.
The gas always assume the shape and the volume of its container. So if I tell you what's the volume of this gas, you will tell me it is, for example, 1. But what's the volume of this gas? You will say it's 3. It's the same gas, but I expanded the place. So always the volume of the gas is the volume of the container. Clear? Good. Yes. Gases are compressible. What do you mean by compressible? You can make them in a smaller volume. Compressible means you compress them and become in smaller volume. So if I put pressure on this one, on this volume, I can make it smaller volume, and so it is compressible. Density of the gas is always low, much lower than liquids or solid. The density is very, very low for gases. All right? And the density depends on the temperature and pressure. Depends on temperature and pressure. And we're going to deal with always temperature and pressure, very important. Okay? Gases are homogeneous. What do you mean by homogeneous mixture?
We can't see the difference.
We cannot find, for example, if I have a container contain different.
We can't distinguish between
together, and you cannot differentiate between them. Good. The pressure P, we're always going to refer to it in this a lot. Pressure equal to force over area. It's the force over area. When you have a certain area and you put your, or you even stand, if you are standing here, okay, you're putting pressure on this platform. Always pressure is equal to force over area. Now, the force, we measure it with Newton. So we say a Newton is the unit for force, and it's equal to kilogram times meter per second square. You have to know this and memorize it. The pressure P, that's very extremely now important. The unit that we use for pressure, the SI unit, is called Pascal. Pascal. And the Pascal is equal to Newton over meter square. All of these units you must memorize. So what's the unit that we use for force?
Newton.
Newton. What's the unit that we use for pressure?
Pascal. Newton.
Pascal. Pascal. And the Pascal is equal to what? Newton over
per meter square.
Meter square. Newton per meter square. Or it is, because Newton is 1 kilogram times meter over second square, Pascal is kilogram per meter over second square. You must memorize all these relations. Clear? Memorize them. Good. Another unit for pressure, which is much more important than the Pascal. Another unit, which is called AT, atmosphere. And we are going to refer to it always as ATM. ATM. All right? Very important. So for pressure, we're going to use 2 units. What's the first unit?
Pascal.
Second unit? Pascal. So we have atmosphere and Pascal, all units for pressure. All right. And as I said, atmosphere is much more important than Pascal. Is there a relation between atmosphere and Pascal? Yes. You don't have to memorize this number, but 1 atmosphere equal to 101,325 Pascal. Don't memorize this number. Understand that what are the units that we use for pressure? For pressure. What's the unit we use for
Pascal.
pressure? Pascal or atmosphere. ATM. Is there any relation between ATM and Pascal? Yes, this is the relation. Don't memorize it. Another relation that I want you to memorize is 1 atmosphere, ATM, equal to 760 milliliter Hg, or equal to 1 atmosphere equal to 760 torr. So in this case, 1 torr is equal to what? What?
0 milli. نفس التقسيم.
1 atmosphere equal to 760 millimeter Hg, and 1 atmosphere equal to 760 torr. So a torr is equal to what? Millimeter Hg. Is this clear? What do I mean by 760 millimeter Hg? If you have a tube what do I mean by, if you put a tube of mercury and the height of this tube 760 millimeter and of Hg, millimeter Hg, if you put a tube here and you fill it with Hg, all Hg, what's Hg?
Mercury.
Mercury. If you have the tube height is 760 millimeter Hg, this means the pressure of this tube, what's the pressure of this tube? Pressure of this tube is equal to 1 atmosphere. Is this clear?
So what's the direction of the pressure?
Down. Down, of course. The pressure, as I said, pressure is like this. This is 176. Yes.
Can you repeat the last point?
Last point. Okay. Pressure. Pressure is very important. We have 2 units to measure pressure. We have Pascal and atmosphere. Pascal and atmosphere. Is there any relation? Yes. 1 atmosphere equal to 101.325 Pascal. 101,325 Pascal. Don't memorize this number. Do not memorize. I will give you this number in the periodic table. But what I want you to memorize is 1 atmosphere is equal to 760 millimeter Hg. What do I mean by 760 millimeter Hg? If you have a tube filled with mercury, the height of this tube, I will bring another tube here. Tube like this, and put this tube on something like even a table. This is a small table like this, and I put this tube on it. The height of mercury in this tube is 760 millimeter of Hg. Then what will be the pressure on this table? The pressure on this table, what will be the pressure on this table? The pressure will be equal to exactly 1 atmosphere. So 1 atmosphere pressure is equal to 760 millimeter Hg. Or 1 atmosphere is equal to 760 torr, which is tertially, but it's the same thing. So a torr, 1 torr is equal to 1 millimeter Hg. Is this clear? So when we want to measure pressure, we use, what are the units that we are going to use in this chapter? We're going to use atmosphere. We're going to use Pascal. We're going to use millimeter Hg. We're going to use torr. All of these 4 are the units for pressure. Atmosphere, Pascal, millimeter Hg, torr. Is there any relation between atmosphere and Pascal? Yes, this is the relation. This is the relation. Do you need to memorize it? No. Don't memorize this number. Clear? Okay. Is there any relation between atmosphere and millimeter Hg?
Yes.
What is this? You need to memorize. What is it?
One atomic
atmosphere. One atmosphere
equal 760.
This you have to memorize. 1 atmosphere equal to how many torr?
So 100. Oh, sorry. 760 torr.
Exactly like millimeter Hg. Same thing, same word. Is this clear? Is this clear for pressure?
Clear.
Good. Now, if you have 1 kilogram of air, okay, and you want to calculate the force of 1 kilogram, you multiply the force by density, okay, and you will have the force by density. This will give you the force, which is 10 Newton. If you have this force, we want to know what's the pressure, what is the pressure of 1 kilogram of air over an area of 1 centimeter cube, 1 centimeter square. So 1 centimeter square. So if you have 1 centimeter square like this, 1 centimeter, and you put pressure of air like this in it, which is equal to 1 kilogram of air. 1 kilogram of air. Then you take the kilogram of air, multiply by density. This will give you the force, which is 10 Newton. You divide this 10 Newton by the area. 1 centimeter by 1 centimeter is 1 centimeter square. I want to change it to meter. It will be 0.0001 meter square, and the force will be 1 times 10 to the power 5 Pascal. So you can see that the force of 1 kilogram of air in 1 over 1 centimeter cube is equal approximately to 100,000 Pascal, which is approximately equal to what?
Atmosphere.
1 atmosphere. You remember the 1 atmosphere is approximately equal to 101,325 Pascal. So if it is approximately 100,000, so this is 1 atmosphere. So the 1 atmosphere is approximately the force of 1 kilogram of air on a centimeter square. Clear? Okay. How do we measure the pressure? We measure it by 2 methods. By a barometer. This is called the barometer. Barometer. And the barometer is very simple. You have a ball here, ball full of mercury. This is all mercury. And you have a tube. This tube is evacuated. What do you mean? What's the meaning of evacuated?
No
air.
No air.
Without air?
No air, nothing. Evacuated means no air, nothing there inside at all. So, because it is no air, no pressure from here, the air is putting pressure on the mercury in the ball. The mercury will start going from here to here until it reaches to here. And then you measure the pressure of the air by the height of the mercury. And if you have 1 atmospheric pressure, you will find that this side is 760 centimeter or 760 what? Milliliter Hg. This is how we measure the pressure by this instrument. What's the name of this instrument?
Barometer.
Barometer. Barometer. What's this consisting of? A tube which is what?
Evacuated.
Evacuated. And a ball which is full of mercury. There is ball, and you put the tube which is evacuated in this ball, and then the mercury will go up like this. All right. Now, that is the barometer. I want now to define another thing: standard temperature and pressure. When you have the pressure equal to 1 atmosphere and the temperature equal to 0 degree C, or equal to what's Kelvin?
273.
273.15 Kelvin. We call this STP. STP. What's STP stands for? Standard pressure and temperature. Standard temperature and pressure. From now on, when I tell you STP, what do you understand right away? The temperature is equal to what?
273.
Centigrade and or 273 Kelvin. And what's the pressure?
180.
Very important to memorize these 3 letters: STP. STP. One more time. STP. STP. Temperature is 0 and pressure is 1. That's it. Clear? I hope so. Now, how do we measure pressure? We measure pressure. You multiply. This is very important equation. You must memorize. Pressure equal to height times density times gravity. All right. That's why if we want to do it for, I want you to calculate now. Calculate the pressure exerted by a column of mercury, which is 70 centimeter height. So we have a mercury, and the height of this mercury is 70 centimeter Keep this in mind. We'll come to it. And write the density. The density of mercury is very high. It is 13.5951. Write this because we'll go back and solve the problem in a while. Okay. I want to know what's the pressure of this column of mercury. Okay. What's the density? 13 point what? 5951. Good. Let's apply it here. What was the height?
70.
70 what?
Centimeter.
Centimeter. I want it in meter.
0.7.
0.7 meter. Okay. What was the density of mercury?
13.5951.
13.59. Yes.
51.
51. I take it from you. I don't know. Okay. So this is the density. Sorry. Density gram per centimeter cube. So gram per centimeter cube. Okay. We'll keep everything in centimeter, but even though gram, I want to change it to kilogram per meter cube. I need to change this to, sorry. So I'll take the.
يطلع دكتور multiply by 10 to the power 7.
13.5951 gram per centimeter cube. I want to change it to meter cube. What should I do?
We multiply
1,000.
Our
actually a meter equal to 100 times 100. It's 100
to the power 3.
100 centimeter all to the power 3. This means 10 to the power 6. Okay, and this is 1,000.
So multiply by 10 to the power 3.
Okay, 1 meter cube, and then the gram I will change it 1,000 gram equal to 1 kilogram. The gram will go gram, centimeter cube will go centimeter cube, and then this is 10 to the power 6, and this 10 to the power 3. The rest is 10 to the power 3 kilogram per meter cube. And what's the gravity?
9.8.
9.8066. The gravity 9.8066 meter per second square. Meter per second square. All right, and this way you have the unit at the end. Multiply this and you'll find the pressure. What is it?
9.33 multiplied by 10 to the power
3 times 10?
10 to the power 4.
4. Are you sure?
Yes.
Okay. Who got it the same answer?
Doctor, I got it 9.33 times 10 to the minus 5.
Impossible.
No, first answer is correct.
Yeah, 9.33 times 10 to the power plus 4. It must be, yes. What's the unit?
Pascal, ATM.
This is Pascal. Yes. Very important. Can you change it to atmosphere?
Yes.
1 atmosphere.
101.
You don't have to memorize. Remember, 101.325. 325. I don't memorize myself. 325. to Pascal. Okay, what's the answer? Yes.
0.9.
What?
0.92.
I hope everybody got the same answer.
Yes.
Good. The other instrument that we measure, what's the name of this instrument? What's the name of this instrument?
Barometer.
Barometer. Manometer.
Manometer. There's another instrument, and it's very easy. You can see here we put the gas in one side, and we have U-tube. All right. We can have either vacuum, the vacuum here. Then what will be the pressure of the gas? The pressure of the gas, if this is vacuum, this means the pressure is equal to what here? If there is vacuum, nothing there, the pressure will be what? 0. Vacuum or evacuated. Vacuum or evacuated. This means the same word. If it is evacuated or volume, then the pressure is caused only by the gas. What's the pressure of this gas in this case? Is equal to exactly pressure of gas equal to H. This H. Why? Because the pressure difference between the height, this is the pressure of the gas. The vacuum is not putting any pressure, and the gas was able to raise the gas by this difference in pressure, and so the pressure of the gas is equal exactly H, millimeter Hg. If there is a pressure outside, we have to know what's this pressure, which is pressure atmosphere, pressure outside, and then what will be the pressure of this gas if it's open, not closed like this. This is closed, this is open. What will be the pressure of the gas? The pressure of this gas in this case will be H, pressure of atmosphere, plus H, because it goes more pressure here. If the pressure of the gas is less than the pressure of the air outside, then what will happen? If this is the gas here, we have gas here, and connected to a tube, U-tube, like this. And let's assume that this U-tube, like this, and let's assume that the pressure outside, this pressure, this is the pressure of atmosphere outside, is higher than the pressure of the gas here, pressure of gas. Then what will happen to the mercury? The mercury will be like this. And this H will be the difference. So in this case, which is higher in pressure, the pressure of the atmosphere or the gas?
Atmosphere.
P atmosphere is greater than P of gas. But in this case, in the case that we have here, pressure of gas is what?
Greater than pressure of atmosphere.
I hope this is clear. Good. Good, we solved this already. Now, let's stop here for a while.
Doctor?
Yes.
Can we return to the last page, please, for a second?
Just a second, just a second. Let me do this first. Okay. Now, All right. Now I send you the attendance right now, very quickly. I'm going to take the attendance. You have 1 minute. Go ahead and go to the site I sent you on Microsoft Teams and press present very quickly.
سكر يا دكتور سكر.
يقول كلوز يا دكتور.
ليش كلوز؟
سوي ريفرش للصفحة.
أنا فتحت عندي يا شباب.
مفتوح أنا دكتور طلع عندي.
مفتوح يا دكتور.
الآن توني أرسلت الآن شوفوها وادخلوا بسرعة. لكم 1 minute only quickly.
بس مرة واحدة تكفي على طول يا دكتور؟
مرة واحدة تكفي إن شاء الله.
دكتور مكتوب 21 سبتمبر.
نعم.
مكتوب 21 سبتمبر.
عليك التاريخ القديم ما غيرته. بس ما عليه هو حيحسبها اليوم دونت وري. يا شباب you have 15 seconds to go. Okay, I'm done. Okay, good. All right. All right, next. We're going to continue discussion. Okay, we have here many laws. Before I go to these laws, there are 4 important, very important relation in gases. We are still in gases. What's this? We already talked about this. What's this?
Pressure.
What's the unit that you use for it?
Pascal.
Atmosphere.
Atmosphere.
We're going to use Pascal, but very rarely. We're going to use atmosphere mainly. And we know one thing I always want you to know, 1 atmosphere equal to how many milliliter Hg?
760.
Number, never forget this number. Or 7, or what's the other name for a millimeter Hg?
Torr.
You have to memorize this. Now, pressure, atmosphere. Temperature, we're going to use, what's this?
Kelvin.
Kelvin. Volume, we're going to use?
Meter.
Liter. And then N, we're going to use? Moles. These are the 4 important relation in gases. All right.
You mean numbers? Yes.
Huh?
You mean numbers by N?
N number, yeah, number of moles. N is moles. Number of moles, yes. All right. And from now, I will give you what is called the ideal gas law. Write this word. Ideal. What's ideal? What's the meaning of ideal?
مثالي.
Perfect. Ideal means perfect gas law. All right, equal PV equal to nRT. Write it and memorize it extremely well. What is this? Again, what's the name of the gas law? Ideal gas law. Ideal gas law. What is it? PV equal to nRT. What's P?
Pressure.
What's the V?
Volume.
What's the unit for pressure?
Pascal or ATM? Atmospheric pressure.
What's the pressure volume? What is it? What's the unit?
Liter.
Cube.
Liter. What's N?
Number of moles.
Number of moles. And how? What's the unit?
Moles.
Moles. And what's T?
Temperature in Kelvin.
Kelvin. Oxygen. And then R is called
constant.
Gas constant. All right? Gas constant. And I want you to know what's the unit for R.
Unitless.
Joule per
the unit for R. The units that you have here. This is atmosphere, this is liter, this is mole, and this is Kelvin. So what's the unit for R?
There is no unit.
Atmosphere times liter divided by
mole. Multiplied by Kelvin.
Kelvin. That's for R. Okay, the unit is this unit. Now, I want you to know one more fact. If you have a gas, if you have 1 liter, if you have 1 mole of gas at 0 Kelvin, 0 degrees C, sorry, 0
Kelvin, right?
No, 0 degrees C and 1 atmosphere, 1 atm, or I have 1 mole of gas at STP. What's STP stands for?
Standard temperature and pressure.
What's standard temperature and pressure? What's T for standard temperature?
T is 0 Celsius and P 1 atmosphere.
0 degrees C and 1 atmosphere. Good. Based on the information that you have, if you have 1 mole at 0 degrees C and 1 atmospheric pressure, it was found that the volume will be 22.4 liter. Write this number and memorize it. 22.4 liter. This is 1 mole of gas at STP. Based on this,
any gas, doctor?
What's R? You have now the pressure.
Gas constant or?
Huh?
Gas constant.
Yeah, what's the, find the value of R. Tell me what's the value of R.
.0.08205.
0.0821 exactly. So what's the information that I want you to understand now? That if we have 1 mole of a gas at STP, then what's the volume of that gas?
22.4 liter.
22.4 liter. If you know this information, can you calculate R?
Yes.
Yes, because you have this pressure is 1, liter is 22.4, and number of moles 1, and Kelvin is 273.15. The only thing that you do know is R. Calculate R, you will find that R is equal to 0.0821. Again, I don't want you to memorize this number. I want you to memorize this number. What's the volume of a gas at STP?
22.4 liter.
That's what I want you to memorize. Is this clear? Okay, any question?
Yes, doctor.
Yes.
22.4 liters. Is that applied to all gases or just ideal gas?
Any gas. Clear?
Doctor.
Good. Very good. Now, remember that PV, you have to memorize this ideal gas law. What is PV equal to what?
nRT.
nRT. R is what?
Gas constant.
Constant.
And if you keep N constant and T constant, if you keep, for a gas, if you keep N and T constant, then this whole thing become what? Constant.
Constant.
And then you will have PV, P1 V1 equal to P2 V2 equal to constant. So if you keep N and T constant, then you reach what's known as Boyle's law. Boyle's law. Boyle's law, it says that the pressure P1, you have to memorize this, P1 V1 equal to P2 V2 equal to P3 V3, but it must be what? At constant?
N and T.
Temperature and mole.
T. All right. Or P1 over P2 equal to what? P1 over P2. Take these two together.
V2 over V1 over V2.
No.
V2 over V1.
Exactly. V2 over V1. Is this clear? That is, both are Boyle's law. This is Boyle's law, this is Boyle's law, and or even P1 V1 equal to P2 V2. All this is Boyle's law. Good? Very good.
Doctor, I have a question.
Yes.
Could we say that Boyle's law is the law of the isothermal process?
Isothermal? Isothermal. Yes, it is. Well, no. Pressure is different. No, it's thermal process, not isothermal. Isothermal, yeah, it is isothermal. The same thermal, yes, it is isothermal process, yes.
Okay, thank you.
Okay, good. Next, solve this problem. A skin diver breathed at surface, filling his lung with 5.28 liter. So when he was outside, his the volume of the liter of the air, the volume of the air in your lung is 5.82 liter, and the pressure was 1 atmosphere. If you go down, if somebody take this in his mouth and go down until the pressure is 1.92 atmosphere, then what will be the volume in your lung? Give me an answer quickly.
Uh, 2.6 liter.
No, it's not 2.6. Wrong.
Shouldn't we just divide 5.8?
Doctor, I find 3.03.
Yes.
Yes.
3.03. Yes, divide this number by this number. Actually,
oh, I forget.
And it will be 3.03. Good. Next, if we have PV equal to nRT. Now, if we take P or V over T. V over T is equal to what? V over T.
Constant.
NR over
NR over P. All right. V over T equal to NR over P. If I keep N and P constant, then what will happen? V1 over P1 equal to what?
V2
over P2 is equal to V3 over P3. All right. But what's the N and P must be constant. That is known as Charles and Gay-Lussac law. Charles law or Gay-Lussac law. Don't memorize, don't forget the name. Or V1 T2 V1 T2 equal to what?
V2 T1.
V1. Is this clear? Both of this are
Yes.
Charles law or Gay-Lussac law, but what's the condition? Must be N and P constant. Okay, very quickly, let's solve this problem. A sample of argon gas that originally 14.6 liter at 25 degree C was heated to 50 degree C. What's the new volume? Quickly calculate it. Don't forget to change it to Kelvin. Exactly. I need the volume.
$15.8.
This 15.8 liter. What you should do, multiply the volume by the second temperature, T2, which is this temperature, but change it to Kelvin, and then divide by T1, which is this temperature in Kelvin, not in degree C, and you have the answer of 15.8. And with this, the lecture is over, and see you inshallah Wednesday.
Thank you.
The lecture is over.
دكتور.
Yes.
الحين اللي قالوا لك
Yeah, I am in the office. Yes.
اللي عندهم اختبار يوم الأربعاء هل كان في نفس الوقت الساعة 10 يعني؟
لا ما أدري والله بس كان.
إيه لأن يعني لو قلت كل واحد عندك اختبار يوم الاثنين بيقول إيه بس إنه ما يكون عنده تعارض في نفس الوقت.
صح.
يعني
صادق.
لأن أنت تسألهم هل أحد عنده اختبار يوم الأربعاء يقول لك إيه عندي اختبار، هو تلقاه عنده العصر ولا المغرب يعني، لأن ما أعتقد في كويز يكون الساعة 10 أو 10:30 يعني.
اختبار الماث يا عزيزي الساعة 7.
يا
اختبار عليه
سلام،
زي
ما ساعتين.